Well, good morning, everyone. And again, welcome to the Emiquon, the 15th annual Emiquon Science Symposium. We appreciate your interest in taking time out of your day to share with us and our researchers a little bit of what's going on at Emiquon in the past and maybe what's going on in the future as well. Hydrology, which is all about water. It's the amount of water, the timing of water, the flow of water, the duration of water, etc. Hydrology is usually one of the most important considerations when planning and implementing wetland restoration and long-term management, as it's a key driver for wetland plant and animal communities. And we thought that starting out with an overview, an update on Emiquon's hydrology would provide a good introduction to the project. And as Tom mentioned, a base for some of the presentations to come that will share responses of some plant and animal communities to changes in hydrology at Emiquon. And also provide a little background for people that aren't familiar with Emiquon potentially. So if you're not familiar with Emiquon, I guess even if you are, the fact is that Emiquon is in West Central Illinois. It's part of what we call the Emiquon complex that consists of the Chautauqua National Wildlife Refuge and Emiquon National Wildlife Refuges, owned and managed by the U.S. Fish and Wildlife Service, and the Emiquon Preserve that's owned and managed by the Nature Conservancy. So we're about a little less than an hour southwest of Peoria. And if you haven't been here, we hope you'll come. 100 years ago, this area around Thompson Lake and Flag Lake, shown here, along with a lot of other diverse areas, was phenomenal for wildlife productivity. The diversity and the abundance of wildlife was renowned. And so in this picture that's a little over 100 years ago, the Illinois River is a ribbon going through that wetland or those wetland complexes this is about an 8-mile stretch of the river. The top of this is looking to the west, so north would be to the right. And this is between Havana and the little town of Liverpool, showing you how diverse the habitat was out there. But as our country grew and with the advent of large machines, people started building earthen berms or levees around portions of the floodplain and converting those areas to agriculture. And it just didn't happen around Thompson and Flag Lake that we're going to focus a lot of our energy today on, but it also happened up and down the Illinois River. So over time, what had once been phenomenally productive and very diverse habitat was converted to still very productive, but not very diverse agricultural lands. And as that happened, we lost a lot of ecosystem services that are provided by floodplains when they're in their natural state. And today, the Nature Conservancy, well, in 2000, the Nature Conservancy announced the largest private conservation purchase in the history of Illinois when we bought most of Wilder Farm here. Currently, we own about 6,700 acres, primarily the Thompson Lake Drainage and Levee District, and a few areas along the bluff that are shown here by the green line. As we started thinking about restoration and long-term management of this wetland complex, we pulled together a group of 40 scientists and land managers that we call the Emiquon Science Advisory Council. And it quickly became apparent that thinking about hydrology was paramount in our planning process. And as we thought about hydrology with this conceptual picture here of the hydrology of Emiquon, we identified that there were a lot of things that we really didn't have control of, and in the near term locally weren't going to have control of in terms of managing the hydrology of Emiquon. But as we bought this property, again, the map on the left with the dotted yellow line or the dashed line is the levee that's around the Thompson Drainage and Levee District. And we're going to talk quite a bit today about what's in that yellow circle was a connection between the Emiquon Preserve and the Illinois River. When we bought the property in 2000, there were a couple of old diesel pumps that had been used starting in the 1940s down along the river to pump water into the river. and also a couple of electric pumps that were put in 1980. And those diesel pumps were no longer functional, but we did have those electric pumps that at least gave us the potential to manage hydrology a little bit, and that we could pump water out to the river when they were working, although they were not in that great a shape. More recently, in 2015, we started construction. In 2016, completed our new water control structure in the levee shown there. So Emiquon on the upper right, the Illinois River on the lower left, and that water control structure, a one-of-a-kind water control structure that incorporates both gravity flow through concrete culverts and 2 submersible pumps that are capable of pumping to the river. So for gravity flow, we can move water either direction. And for pumping, we can only move water from Emiquon to the river. But it provides us an opportunity to manage water levels, to also manage connectivity and the movement, not only of water, but of organisms between Emiquon and the Illinois River. And another function of this is to facilitate great science. So what I'm going to do now is 3 things in the time that remains. I'm going to provide a very brief summary of the hydrology, so the water levels and some of the management that's taken place since before we started the restoration, so going back to about 2003 up to the present. I'm going to go through that pretty quickly, and then I'm going to focus some energy and share some numbers about the last year, hydrology of the last year, because we made a couple pretty, we had a couple pretty important management events. We've had some of those in the past, but I want to share a couple that took place in the last year. And as Tom said, some of the future presentations this morning will use some of that information, I think. And then thirdly, last but not least, I want to talk a little bit about our plans for the future at Emiquon, at least our current plans. So that dashed line there in 2007 is when we hit this divide. Prior to 2007, in recent history, Emiquon had mainly been used for agriculture, and restoration started in 2007. And this is a hydrograph, we might call it, a graph of water levels inside the Emiquon Preserve, inside that Thompson Drainage and Levee District. So the x-axis is time, starting back in 2003, coming up almost to the present. And the y-axis is the water surface level. So as the river goes, or excuse me, as Emiquon, as the water level goes up, that line goes up, and as it goes down, the line goes down. The green line is with no management, essentially. So that's water from precipitation. When it's going up, it's from precipitation mostly, a little bit of runoff from 1,000 acres of the bluff adjacent to the property. When it goes down, a green line is probably from evaporation and evapotranspiration. The yellow dots and lines indicate that we were pumping water out to the Illinois River using those old electric pumps or the new ones. The red lines show gravity flow into Emiquon, and we'll talk more about that in a minute. And then the blue lines show gravity flow from Emiquon out to the Illinois River. And so a few highlights with the orange arrows here. In 2007, as the restoration started, we pumped the water down so we could try to eliminate the existing fishery that was mostly rough fish, especially common carp and grass carp, to start restoring a new fishery. Then in 2010, the water had come up considerably from precipitation in 2008 and 9. And in 2010, we had a gift that allowed us to construct our public use area. So we ran those old pumps to lower the water levels a few feet to facilitate that construction. And then the record flood of 2013, it was an early flood in the spring. It was in April that it crested. And for over a week, water flowed over some of our levees into Emiquon, significantly raising the water level and the volume of water. So gravity flow in, but it wasn't managed flow in. it was over the top of the levees that we really couldn't do anything with. Then over the ensuing couple of years, we didn't really manage water levels. The water levels went up and down from precipitation and evapotranspiration, but not a lot of change within years or among those 2 years. And then another small flood, a July flood in 2015 brought in water for a couple of days over a very small section of the levee. Similar that following winter, the winter of 2015-16 and January of 2016, we had water coming over a small section of the levee for a very short period of time. And then in 2016, as we've said a couple of times, the new water control structure became functional. And we gravity flowed here, shown in blue, gravity flowed water out to the river, trying to lower water levels and restore a more natural hydrology with some fluctuations from season to season and also from year to year. Again, we did that pretty successfully in 2017, although the river didn't cooperate. And so by the time the river got down low enough to gravity flow water to the river, it was late August. And so even though we could drop water levels nearly 3 feet that year, we didn't really get a lot of plant growing that year because it was too late in the growing season. So the following year, we decided to bite the bullet and use our pumps. And even before the river was ready for gravity flow, earlier in the season, in late May, we turned on those pumps to reduce the water levels in Emiquon, to restore that low water period of the summer when plants can grow. We planned to do a similar thing in 2019, but we had some difficulties with our pumps, so we didn't do much pumping. We couldn't gravity flow much in 2019 because the river was too high. And then last but not least, I'm going to talk a little bit more in depth now about the changes that took place and the management that was actually done this last year. So this is a similar graph, but I'm just focusing on the last year and a half or so. So we're going from January of 2020 up to almost the present. And you can see there that we had a big water drop starting in June. In 2018, we had started pumping the water down in late May. We held off until June in this past summer. And over a 58-day period, we pumped about 2,000 pump hours, and we were able to drop the water levels a little over 4.5 feet. And again, that's to condition sediments, in part to condition sediments and to grow plants. And here's, if you're interested, some more technical numbers on what happened. So we started the pumps on the 9th of June last summer. At that time, the water surface elevation was just a little bit above 432.5 feet above mean sea level. We had about 4,450 acres of surface water out there in Emiquon, or a volume of about 6.1 billion gallons. And the diagram there to the right shows everything in color on that diagram except for the Illinois River. But those vivid colors there show surface water from less than 2 feet deep, so just over zero water, a little bit of water, surface water, up to as deep as almost 12 feet out in Thompson Lake. So that's what it looked like when we started the drawdown. And if we were out where that arrow is, looking to the north, we would see a scene like this on the 9th of June. So this is looking north, if you're familiar with Emiquon, from the pump house ditch, Thompson Lake on the left, Flag Lake on the right, Chautauqua National Wildlife Refuge on the upper right there, and almost everything out there with the exception of the roads along the pump house ditch and the levee was underwater. The green, dark green you see is mostly typha or cattails. There's a bed right under Flag. There's a large lotus bed, and you can actually see down in the water in places and see some submerged aquatic vegetation. So that's when we started. And then we pumped for a total of 58 days, ending about the 6th of October. We had dropped the water level, as I said earlier, just over 4.5 feet. We had gone from 4,450 acres down to 2,833 acres of surface water. So we had exposed over 2,800 acres of what had been water before we started pumping. So we reduced the surface acreage by about 63%. We'd gone from 6 billion gallons to about 1.5 billion gallons, or 1.4, which meant the volume of water out there was reduced by about 76%. And this is the way it looked on the 6th of August. So again, the gray that you see there is land. The colors that you see is surface water. Thompson Lake is still pretty decent size. Now the water is more like 8 feet deep in the deepest of Thompson. Flag Lake on the right has gotten considerably smaller, and there's a lot of area out there to grow moist soil plants. And so if we look from about that same vantage point, you can see Thompson on the left, Flag on the right, and a lot of that green out there now is land that has been dried. It was previously underwater and has now been dried. I'm going to show you another view of this. We're going to go back out to the pump house. So the Illinois River on the right there, the green line is the levee around our property. The orange circle is where the pump house is. And those little lines, the yellow line here is a mission that we flew almost weekly with our drone during the drawdown. So we're going to start over the river. We're going to fly the drone out over the wetland and take a look at the response of the vegetation. And Josh Osborne will be talking more about that later in this session. And then we're going to get down close to the water, and we're going to back up and let you see what it looks like down into the water. And so we have four dates that we're going to show: about the beginning of the drawdown, and then July 28th. So about a month into it, a month later, August 28th, and then September 29th, when evapotranspiration had continued to drop those water levels. And we're out over the river with the drone, and we're flying to the west toward Dixon Mounds. And you can see the changes in the vegetation. In the upper left, initially, we had a lot of submerged aquatic vegetation. As the water got shallower, we started getting more floating leaved and some emergent vegetation. Then it was pretty dry in August, and some of that actually started drying up and was so dry that the plants weren't growing. And then by September, we had some precipitation, and those moist soil plants had started growing. I'm going to speed this up a little bit. You can see the lotus beds there. And then we're going to drop down close to the water surface. And I hope this doesn't make you air sick, but then we're going to back up. So we're about 20 feet over the water. You can actually see down into the water and see the different types of plants. We're out in the deeper water now, so a lot of submerged aquatic vegetation. As we get closer to the levee, we see later turning into moist soil plant vegetation growing. And it gets pretty lush by September after we'd had some rains. And then again, back over the river, looking out across there. So that shows you what it looks like from the air. This shows you what it looks like from the ground. A lot of vegetation growing there, a lot of moist soil plants, and a lot of seeds in that right diagram. A couple other things I'd point out that happened last year that you're going to hear about today. One is we did a little bit of pumping for a project to evaluate what we call a fish ladder. So here's the fish ladder. We're at the river looking into Emiquon, or in toward Emiquon, and we were pumping. Most of the pump water then was recirculated back into Emiquon, but a little bit of that water was brought into these tubes to power this fish ladder called a steep pass that Kara Phelps will talk about later. I'd also mention that this was the first time that we were able to bring water into Emiquon in a controlled way. So this is a video inside Emiquon looking out toward the water, out toward the river through the water control structure, or at the water control structure. And you might be able to just, pardon me?
1 minute, Doug.
Oh, you might be able to see there that water's actually flowing in. Okay, so here's a little bit of the information. Over a 24-day period, we were trying to flood vegetation. We raised the water levels a little bit over a foot. We flooded about 600 acres of ground out there. So you can see that we added a little bit of water in about 0.6 billion gallons of water. To keep fish that we didn't want out, we put screens in. These screens are about a 1/2 inch by a 1/2 inch. And this shows where the screens were. So we're looking out toward the river to keep the big fish out. And we also collected the little fish that came through the screens. We collected 16 species, and the ones in the 2 columns on the left had previously been stocked in Emiquon, or they'd been documented in Emiquon, but we actually got some new fish in as well on the right. And then finally, as for our future plans, we plan to do some fish ladder research over the next several months. We plan another drawdown this year, although we'll be starting a little later, and some of the folks may be talking about why we might consider drawing water levels down later. Then precipitation, we anticipate will bring water level up a little bit. And if it doesn't, and if conditions are right, we will then evaluate whether we want to bring water in from the river next year. So with that, Tom, I'd be happy if we've got a chance to answer a question or